Welcome back, everyone. Hope you all had a nice break. Welcome back to the second part of the presentation. This part will hopefully be a lot shorter. You heard in the part one the theory. You heard in part one why we were doing things, and now in part two, I wanted to give you a, live demo of how we might go about doing one of the practices of XP, which I think shows a lot of value, and that is TDD, test-driven development. How would that work? So this will be a live demo, so hopefully the demo gods will be kind with me, and hopefully things will work out. But just in case, I had already done this earlier today, and I had made a backup of the code. So in case something goes wrong, we can always copy and paste from already existing code and hopefully proceed. So bear with me if something goes wrong. Now, what I'm going to simulate is a brand new project and starting out with a test and test-driven development first. Now, this doesn't necessarily mean that TDD is only for brand new projects. It could be useful anytime you do development. In fact, think of tomorrow going into the office and you're maybe required to implement some piece of functionality. Well, try it out. Try what I'm showing you. Just try it out to give it a shot, see how it feels. What we would do is we would, again, start with writing a test first, which makes it red because it breaks, because it's testing functionality that isn't there. We're going to make it green by implementing just enough functionality to make it work. Then we're going to break it again. Rinse, repeat. We're going to keep doing that. That's called red-green test-driven development. Let's see how that might work. Let's imagine, and so this is, I just created this project ahead of time. The reason I did that is because if I tried to do it from scratch, then IntelliJ, my IDE, would try to download a whole bunch of things, and over Wi-Fi, I didn't want to delay us. So bear with me, this is a project that already exists that I created, but essentially it has almost no code. It just has some, very little code. And I just wanted to show how I might go about doing test-driven development. So let's imagine that I'm being asked to implement a class that says hello world. Okay, straightforward, right? Let's think about it. In our system metaphor, what is a hello world? It's really a greeting, right? So what is our class that does a greeting? It's a greeter. So in the system metaphor of XP, let's call it a greeter, because not only does it give a logical explanation of what the functionality is, but it's clear to everyone, not just us, not just QA, but also to non-technical business people understand what that means. And they can understand what we're working on. If we say I'm working on greeter, far better than if I told them I'm working on JKS. What's that? I don't know. But if I tell them I'm working on something that they understand, then everybody understands. It follows a principle that one of my professors like to use, which is the principle of least astonishment. It's important to not astonish those you work with, at least not in a bad way. So let's call it greeter. So if I'm going to create a class called greeter, and I'm doing test-driven development, well, I need to create a test. Let's go ahead and create that test. So in IntelliJ, how would we do that? We would go about creating a Java class. By the way, is everyone familiar with IntelliJ or Eclipse? Everybody using an IDE? Anybody not using an IDE? Okay, good. So the things that I'm talking about, I personally like and use IntelliJ, and if you're curious, last year IntelliJ crossed over the threshold from Eclipse in that it is the most popular Java-based IDE, which is incredible considering Eclipse is free and IntelliJ costs for the general version, the ultimate version, $500 a seat. So according to Rebel Labs, Zero Turnaround, the folks who make JRebel, their survey of Java IDEs showed IntelliJ crossing over in 2016 to be the most popular Java IDE. Even if you use Eclipse or something else, the concepts that I'm going to show you should be similar, should translate. So, greeting, let's do a greeter test. Okay, here's greeter test. Okay, so the IDE created this test for me. And you might have seen up here something called Infinite Test, right? That is a plugin that you can get for your IDE. I know it exists for both IntelliJ and for Eclipse. And what Infinite Test does is, as the name implies, it continuously runs your unit tests. Remember what we were talking about, that you want to get feedback as soon as possible if you broke something, right? I'd rather get the slap on the wrist right away if I did something silly than wait for a build to happen an hour later. Or worse, one of my colleagues to check out code and find out I broke him or her, or the worst ever, which is a customer finding a bug. The faster I find it, the better it is. Infinitest, and there are other plugins, but I personally like Infinitest. Infinitest runs any tests that have changed. It's smart enough to know that if either the test has changed or the class under test has changed, it runs only the affected unit test. And it runs it and then tells you the results right away. In order, I believe in Eclipse, all you need to do is save the file or save the test, and it'll run it. In IntelliJ, you just need to do one thing, which, how do I make this window? Here we go. Okay, you just need to do one thing.
You can move that down to the bottom.
Okay.
Just drag and drop the whole thing.
Great, thank you.
Yeah.
Okay, thank you, much better. So in IntelliJ, by default, this is not the case, so you would need to set it. You go into the Preferences, go into Compiler, and click this button, Build Project Automatically. If you don't do that, in IntelliJ, you'd have to do Control F9 to build your project. In Eclipse, it builds the project automatically every time you save the file, okay? So in Eclipse, you have to do Control S to save the file, either save the unit test file or save the class under test, and Infinitest will run your test. In IntelliJ, it always auto-saves your file. Within a second or two of you changing a file, IntelliJ will save it. Infinitest, if you click that option, will then automatically run your test. Okay? So just want to show you that. Now, let's create our first test. Okay, so we said the first thing it's going to do is say hello world. Okay, so everybody told me they're familiar with JUnit or testng, so similar concept, so this should not be a surprise. We're going to annotate our test with the test annotation. Okay? We're going to create a public void, and now the name of a test. You might be tempted to say test hello world. You might be tempted to say test, name the method test, or test one. Well, in XP, a recommended practice is to have a very verbose name that precisely describes the functionality that we're testing. And they recommend that you do it in one of two styles. Should, meaning a test name, if I were using that should pattern, would be like this. Should say hello world upon no args. Okay? And just by that name, we can kind of tell what it's supposed to do. Oh, okay, if given no args, I should say hello world. Okay, that makes sense. Another way to do it is the given when then. Given no args, or when no args, then say hello world. Okay? Once again, very clear, verbose, but very clear as to what this functionality is supposed to do. And why is that necessary? Because if a test breaks, if a test fails, or even if a test runs, we can see just in the output of the tests that are run over time, we can see in the output, in the console output or in the logs, we can see what the tests were that were executed, and more importantly, what tests failed. So I ask you, if I have a failure, if I have a test failure, what's more descriptive? When no args, then say hello world, or test say hello, or test one, right? So the more verbose we make it, the better. There's no such thing as being overly verbose. Now, don't make it a paragraph or a novel, but enough to capture the functionality of what the test is supposed to do. That way somebody who sees the build break doesn't need to go into the code. They can just look at the build break and say, oh, when no args, then say hello world broke. Okay, I guess there's something wrong with our no args method for saying hello world. You can know right away what happened. Even a business person, a non-technical person, can look at that and probably figure out, because of our our system metaphor, can know what's going on. Okay? So again, two styles, either the should approach, or I like the given when then. I like naming it, when X, then Y. It's very clear as to what you should do. And optionally, if there is a given constraint before that, like something that you have to have before, given when then. Very clear. So let's say, when no args, then say hello world. All right, here's my first test. What do I want to do? Well, I am a reader test. Oh, notice Infinitest ran, and it showed me a success. And if I move this away, I don't know how to move it. There we go. All right. Notice Infinitest is running right here, and it's telling me, hey, I ran the test and everything passed. All right, everything's cool. Infinitest is monitoring this test. Let's run this test. All right, so I want to test greeter. Greeter equals new greeter. Yay. Oh, wait a minute, it's red. I just made my TDD red. Why is it red?
Doesn't
It
exist.
doesn't exist, exactly. All right, how do I fix that? I go into an IDE.
Control Shift F.
Exactly. I go into my IDE and I create the class greeter. Okay, so IntelliJ is saying, okay, we're going to use the same package. I just called it org sdjug xp for this talk. And by default, it's going to use the current directory, but I don't want to put the real class in the test directory. I want to put it in the main directory. So I'm going to put it in hello main. Okay, now here's my greeter class. All right, infinite test says, hey, success. We just made our test green. So we're seeing red-green testing, red-green refactoring in live demonstration. All right, let's go back into our greeter test. All right, we made it green. What's our next job in XP? What's our next job in TDD? Make it red again. How do I make it red? Let's call some functionality. All right, so I want to call greeter dot say hello. Okay, it's now red. Oh, I don't like it being red. Okay, so how do I fix that? I fix it by creating the method say hello. Okay, and this is where an IDE can really help you. It saves you a lot of typing. Infinite test says now successful. All right, great. Infinite test is happy. I have a success. All right, so I have a say hello. But you know, that by itself isn't going to help me. I need to have it check what that say hello is going to be. So I now need it to be a string message of say hello. Oh, I just failed. Oh, why did I fail? I failed because, oh, I return a void and I need a string. Well, I need to fix that. Let's go into my IDE. My IDE says, hey, I can make say hello, return a string. Awesome. It's now public string say hello, and my IDE automatically returned null. Infinite test says success. All right, great. I made it pass. Time to make it break again. How do I make it break? Let's issue an assert. Anyone familiar with what I'm saying when I say assert? Okay, anyone not familiar? Okay, so I don't need to explain asserts. All right, asserts are how we can ensure that the test is at a state that I want it to be in. Okay, so I'm going to assert not null. Okay, I'm going to say that the message is not null. And once we do it this way, then we should be able to do a static import. Okay, so infinite test has a problem. Failure on this line. Oh, what's the problem, infinite test? Infinite test says it's a failure. Okay, so I guess I got to fix it. So how do I fix it? Let's go into here and let's see what's going on. I said it's not null, but apparently it is indeed null. Okay, so I can't do that. Well, what's the bare minimum I need to do to make it pass?
Empty string.
Empty string. There you go. TDD, we always implement the bare minimum to make the test pass. Okay, infinite test says successful. Let's go back in. Awesome. It's now not null. But that by itself doesn't help me. I want to make sure that it's a particular thing that I'm expecting, right? So I'm going to say assert equals, and notice IntelliJ automatically static imported that for me. And I want to say that it's going to be called hello world, exclamation mark, message. Okay, so now, not only is message not going to be null, but I assert that it's equal to hello world. Oh gosh, that's failing. All right, let's go fix that. All right, so now instead of returning empty string, what do I need to do to get it working? I do return hello world. Okay, I return hello world, infinite test says it's successful. Now imagine many months later, okay? Many months later, I come back, or maybe this is code written by somebody else, right? I come in here and say, oh, what's with the exclamation mark? I don't want it to be all, hello world. I want it to be just a calm voice. I'm gonna want it to be a period instead of an exclamation mark. Boom, right away, I'm notified of the failure. That's the value of TDD, folks, that we're notified immediately that a test failed. And infinite test is smart enough. If you have hundreds or thousands of unit tests, it's not going to run all hundreds or thousands. It's smart enough to know which test is covered, or which part of your code is covered by which test or tests, and it runs just those affected tests. Conversely, if you modify a test, it's smart enough to know which code is affected by that test, and therefore it runs that test and ensures that it works. So this is a way of getting feedback right away. So not only does it inform me or my pair or any other developer of test failure right away, and it allows us to fix it right away, it allows us to, boom, fix our code, fix our breaks right away, and by doing this, we now have documentation. So instead of JavaDoc, folks, I have a method name saying when no args, then say hello world. well, that's pretty clear what this functionality can do, right? I don't need to write JavaDoc. I can write JavaDoc, but the danger in writing JavaDoc is it may go out of date. You know, the functionality might be very different. But by making a unit test, I guarantee that it's up to date because the test has to pass in order for my build to pass. Okay, so next up, let's do something else. Let's write another method. Any questions so far? No? Okay.
Yeah, one question. We recommend somebody to use the same kind of approach that you're doing now, or should they be running more tests and then bigger chunks of tests and then bigger chunks of code, or going flip-flopping big.
In XP, the recommendation is to write a minimal test and then write minimal code. The reason is, if you write a really complex test, you're already determining what the code behavior should be, right? So you're kind of presupposing the functionality. And the risk that you run into is that if you write a really complex test, it's the equivalent of already coding your system, right? And so what we instead want to do is write a test, then write the functionality, and incrementally build both of them up so that any brittleness that you see in the API or the complexity or the general behavior or the concept that we need to refactor it into not just one method, but maybe a group of methods or different classes, you capture that right away as you're in the process of building both up. So you certainly can write one gigantic test and then one gigantic method to implement that test, but that's kind of going back almost to the waterfall model of thinking that ahead of time I know all the requirements, and very rarely is that likely. All right, so thank you for the question. Let's write another test, everyone. Let's say that we do the hello world when there are no args supplied, but if I pass in a name to my hello method, then I want it to say hello to that name. Sounds reasonable, right? So what should I call that? Somebody, what should I call this new method, right? This new test, because as I said, when we pass in a name, we want it to say hello name. Well, that's a good name for it. When name given, then say hello name. All right, well that makes logical sense. Okay, I think somebody who is not me that read that method will probably figure out what that's supposed to do, what the functionality is supposed to do, without having to read through the code, right? Just looking at the name itself can probably understand. All right, so what's that supposed to do? Well, we probably should do a greeter, right? I need to test the greeter, right? So I'm going to do a new greeter, and wait a minute, look at this. I have some duplication here, right? Well, that's not that good. Let's have the courage to refactor, right? Let's refactor now, because whenever you see code that's duplicated, that's usually a code smell, and we generally want to, not essentially reproduce code. So let's simplify. Let's use one of the techniques in JUnit called the before, right? So I like to name it setup, and you can call it whatever you want. And let's set up various things. So if we're going to use greeter in many parts of the code, let's declare it as a class variable. Okay? And actually it's an instance variable. And we're going to instantiate it here. So what am I going to do? I'm going to take this here, there we go. Greeter equals new greeter. Okay, so now I have greeter being defined as before the class is set up, so that each of these test methods can have access to the greeter. Awesome. So now let's test a new method. Greeter.sayHello, and then we're going to give it a name. And what's the name going to be? SDjug. All right. Great. And by the way, that's actually the exact name that I used in my backup code, so good job. All right, so I'm going to pass in the name. Okay, wait, why is this red? I don't have a method that takes a string construct or a string parameter, right? Okay, so let's use the power of my IDE. Oops. Let's use the power of my IDE to create the method say hello. So now we have a new method say hello, right? And now infinite test is happy again. Okay, infinite test is happy again. Now, what are we going to do? We're going to have it give us a message back, right? of a sudden it's red again. Why is it red? Because my greeter dot say hello with the string is void. I need to have it return a string. So let's just let the IDE do the work for us. Great, it has it return, it defaults it to returning the same name that I passed in. Awesome. Let's assert that it's not null.
At what point do you skip that step?
Which step? The assert not null?
Now I start out with it returning null or void, and now I want it to return a string.
Yeah, I'm showing you, you're right, I'm showing you from base principles. You can always short circuit it by, when it builds that method for you, changing the method signature right then and there, right? So I'm kind of showing you in baby steps, but you're absolutely right. That can get tiresome after a while. And you might, if you already know that it's going to return a string, you can go ahead into the method and actually do that. So here, let me show you that right now. Oh, okay. Okay. So for example, if I had this say hello, and if I, okay. And initially, if it said this and I knew that it was going to be a string, I could just change it, right? Public string, and that'll fail, so I could make it succeed by this, right? Okay, so then I go in here, string message equals greeter.say hello. I could assert not null it, and then I could assert equals hello, comma, plus name, plus exclamation mark, right? So if I'm given a name, I want it to say hello, comma, name. All right, well that's, I need to compare it to what I'm comparing it to. Oh, by the way, one of the things I like in IntelliJ, it tells me exactly what each parameter is. Imagine if you have like a method that takes like 3 strings and you have no idea what these strings are or what they are. IntelliJ tells me the first parameter is supposed to be the expected value. So that's really kind of helpful, and IDE is really helping me figure out what that's supposed to be. Okay, and infinite test says there's a failure. Well, what's the failure? It's on this line of code. Oh, look at that. It's a comparison failure. I expected hello, SD jump, exclamation mark, but instead I got empty string. Well, that tells me right away how to fix it. So I go in there, and I say return hello, comma, plus name, plus exclamation mark, right? And I walk away, infinite test will report success. Okay, so this is red-green test-driven development. As you can see, we're building up our tests bit by bit. We're also building up our documentation bit by bit, and we guarantee that the documentation is up to date because the build will break otherwise. And by properly naming our unit tests, we are building up verbose documentation that should be clear to everyone, even non-technical people, just by looking at the name of the test. So if the test breaks, even a non-technical person can say, oh, look, method X or functionality X broke. Everyone knows how that should be fixed. Any questions so far? Okay. So I can understand, and in fact, I was also resistant when I first got into this because I was like, oh, this is really kind of tedious. But once you make a switch in your mind and you realize, well, how else do you guarantee that your code works, right? Now, what I've shown you so far is really basic. You don't necessarily need tests for these because a human can just run it, and with a few seconds, you can tell that it works or not. Okay, now a non-trivial project, possibly hundreds of classes, hundreds of methods. How do you do that? Especially if there's a lot of different branching logic and exception logic, how do you prove that it works? You think you're handling the exceptions, right? But unless you're testing it, the sad paths, you don't know. That's the value of test-driven development. You're continuously delivering thoroughly tested, thoroughly documented code that our pair understands, that even non-technical people can understand our functionality. And because we're thoroughly testing it, we have the courage, we have the confidence that we can refactor without worrying because of complete test coverage. Make sense? All right. Now, I wanted to show a little bit of mocking. Now, mocking is a huge topic. There's lots of different ways to mock. There's so many things we can do with mocking. There's spies, there's stubs. I don't have time necessarily to go into those. In fact, that could be a whole other talk that we could talk about, for a month's Java user group meeting. So let's instead talk a little bit about a particular reason to use a mock. Let's say instead of saying hello, the requirement, the customer comes to us and says, we don't just want to say hello, we want it to be a little bit more personal. We want to say good morning, if it's the morning, or we want to say good afternoon if it's afternoon, okay? So therefore, we need some sort of time-dependent phrase, okay? So how do we do that? Well, it would make sense that maybe we would inject a dependency into our greeter class that would somehow determine the greeting to use based upon the time. Now, this is, of course, a canned example. In real life, we don't probably care about this. But imagine this is some other dependency, like querying a database, or some other external service, or a web service, or a REST service, or a SOAP service, or some other service to get a stock quote, or a database result, or something, right? Now, I'm giving you a canned example, just getting the time of day, but you can easily see something different. So let's go into this, and let's say I want to, what do I want to do? I want to create a time-aware greeting, okay? So what would I do? I would say, okay, so I would want to have a class called time-aware greeting. Now, I'm just making that name up, right? It could be something else, but I just think time-aware greeting makes sense because this is a greeting that varies based upon whether it's morning or afternoon, okay? So we'll inject that as a dependency into our greeting. Now, because that's a dependency and probably it requires some other external service, I don't want to really create it and really have it talk to a web service or to a database call or make a REST call, because that's an external dependency. And if that REST service is down or that database is down, I don't want my unit test to fail because it's going to report a failure. That's not a failure in my code. It's a failure in the integration. So since I'm just doing unit testing for this part, I want to mock that dependency. Now, how would we mock that? With Spring Boot, the default choice these days is Mockito. Does anybody use the Mockito mocking framework? Okay. Anybody use any other mocking frameworks like JMock, PowerMock, anything like that? Mockery? No? Okay. So let's briefly show you. Now, Mockito's huge and powerful, huge. Don't have time to show you everything. I'm just going to briefly show you how we would create a mock object using Mockito. Okay. So I have the greeter in my test. Let's create a mock of this other class that I'm talking about. Time-aware greeting. You can tell that I already created it, okay? Time-aware greeting. I'm going to call it time-aware greeting. But remember what we said. We're going to not instantiate it. We're going to use a mock. Because, again, imagine that it's actually a database or something else, some other external service. So I would annotate it with the @mock annotation from the Mockito package. Okay? The @mock annotation tells Mockito to start out and create a subclass using Java reflection of the real class that I have, and thus allow me to tell it that when a particular method is called, don't call the real method that I wrote. Instead, do exactly the behavior that I'm telling you to do. Therefore, we're not creating a test double, like a stunt double, and we're telling it, don't punch the real actor in the face, let that stunt double take the punch in the face and say, ow, right? So we're going to tell it, I want you to create a mock object, which remember is a subclass. A mock object is a subclass, and use Java reflection to intercept the call, not call the superclass method, meaning the class or the method that I actually wrote, but instead return exactly what I tell you to return. So how do we instantiate this mock? We instantiate it by doing this. Mockito annotations .init mocks this. What that tells us, what that tells Mockito is, I want you to take all the objects annotated with @mock in this class, and I want you to instantiate them. I want you to init them, which basically means subclass them, use Java reflection, create the subclass, and get ready to program the behavior as I tell you to do, all right? Now the next thing is, how do we inject that mock? So in other words, if greeter needs time-aware greeting, right? How do I inject that? Now the preferred way is to use constructor injection or setter injection. What that means is that I would expect greeter would have a method called set time-aware greeting that would then take this time-aware greeting. That way, we tell greeter to use the dependency that I gave it. In this case, not the real class, but the mock that I just built. Now, my unit test is red. Let's make it green. Let's make it green by creating the setter. Okay? So look at that. How nice. Public void, set time aware greeting, taking a time aware greeting, this dot time aware greeting equals time aware greeting. Awesome. All right. And so this thing is now broken. Well, how do I fix that? I need to create a property. Oops. I need to create a property called time aware greeting. Let's create that field. All right. We have the time aware greeting now. Okay. So you see how we've now created a dependency using test-driven development. We've created this dependency and we've enabled it to be injected at test time. Now, how would I inject it in real, for a real class? Any of us familiar with Spring framework? People familiar with dependency injection, right? So if this was Spring, we would do it this way, auto-wired. Okay? That way, when it's really run, when this class is really run, Spring framework would anytime you see auto-wired, the framework would call that method, would instantiate the time-aware greeting, and would pass that in. So when we run it for real, the real time-aware greeting is passed in. When we run it for fake, meaning in the test class, it's my mock object that's being passed in. Okay? So that's an important lesson. I'm going to say that again. Any dependency that you have that you want to mock, you want to provide a setter for it, or you want to enable either constructor injection or setter injection. Constructor injection would be where I create a constructor that takes this time-aware greeting. Okay? You need to provide a way for an external object to be able to set that dependency. That way you can properly mock it. Make sense? Okay? Not seeing any, not shaking heads. So any questions? Okay. So that's an important concept. Always provide an opportunity for externally injecting a dependency. That way you can mock it. Okay? Anything you expect to be mocked.
I think in addition to that, what I've read, yeah, I think they're on timer, I'll fix it, that you should use the constructor over the setter to help with your encapsulation protection, basically.
Right. Exactly.
Because now with a setter injection, you can actually then change the behavior of that object later on, and that may not be intentional.
It's a very good point. That's Paul makes a good point that if any of us are familiar with Josh Block, he's an author of Effective Java, volumes 1 and 2. Josh Block used to be the chief Java architect at Google, and prior to that, he was at Sun Microsystems, where he was very instrumental in creating many of the packages in the Java programming language, including java.util. So the guy who created java.util wrote a book about best practices in Java. Very good book. I thoroughly recommend all of you get it. It's a very helpful book. And one of the things that he talks about, it's not a book you read cover to cover. It's really a book that has a few pages on each topic. And one of the topics that I think is really good, he says, favor immutability. And what that means is, generally a good approach is to have a class that after it's created, it cannot be modified. Meaning you provide getters or accessor methods, but you don't provide setters or mutator methods. So therefore, after it's created, its state never changes. And that way, you're assured of the class being unchangeable, which is very valuable because it is inherently thread safe. An immutable class is by definition thread safe because no one else can modify it. So what to Paul's point, you can use setter injection, that's what I'm showing you right here, but you can also use constructor injection, and you might want to favor constructor injection because in constructor injection, the state of the class is known at creation time and can never be modified. With setter injection, the state of the class is known at creation time, but can be modified later if somebody calls this setter method again and changes it, right? So just an interesting concept to keep in mind. All right, so we now have a time-aware greeting, and this time-aware greeting is now injected. Now let's take a look at this time-aware greeting. Just because to save some time, I wrote it ahead of time, right? This time-aware greeting has a method called getGreeting prefixed for time. Okay? Everybody read that? Is that font too small? It's okay? All right. So really simple, and again, just a canned example, not real code, of course, but it's just checking to see if the local time.now is before the local time.noon. If so, return good morning, comma, space. Otherwise, return good afternoon, comma, space. Okay? Again, canned example, but the whole point is this behavior could change based upon some external value that we cannot control at test time, right? Meaning the test, if I just use the real one, would break whether or not it's run before noon or afternoon. And that's horrible. I don't want the test to break based on an external condition. I want the test to break only if my logic was flawed, right? So that's why I want to mock this. Now, how do I mock this, right? I mocked it by annotating with @mock in my test class, and by initializing the mock in my setup. Okay, the next thing I want to do is I have the mock object, but by itself that doesn't give me anything, all right? This mock object, think of it as an empty vessel. Now I need to populate it. I need to tell Java, or I need to tell Mockito, when a particular method is called on this mock object, don't use the real functionality. Instead, I will tell you what to do. And Mockito will use the power of reflection to do exactly what I told it to do, all right? So how does that work? So here is, if I don't get the syntax right, fortunately I do have a backup. So let's hope I can get the syntax right. Okay, infinite test is all happy? All right, when, all right? When. Okay, so notice Mockito has a method called when, okay? Remember I told you about the pattern when, then? Mockito has that built in. So that's why I like to name my tests when, then, because Mockito uses the same pattern. So when, okay, what's the behavior that I want to trigger the mock, right? When time aware greeting dot get greeting prefix for time, okay? Meaning when somebody calls that prefix, or I'm sorry, when somebody calls that method, and remember, that method, it returns something different based on the time of day. I don't want it to do that. I want it to return something that I can control. Okay, so when that method is called, I want to return good morning. So this is how you use a mock. I created this mock object. I'm now using Mockito to say whenever this mock object is called, I don't care, don't call the real method. Instead, intercept that using, if you're curious, it uses aspects, right? It uses aspects and reflection to intercept that method call and then return good morning, okay? So a call to the mock object for get greeting prefix for time will always return me good morning, okay? So if I wanted to, for example, if get prefix for time took a parameter of an object, for example, or a string, I could actually do Mockito has any string, for example, right? Meaning, imagine that this method actually took a string. I could say, I don't care what string you pass in, any string will match any string, right? Or imagine if instead this method took an object, I could actually use the Mockito any. Any meaning any object at all that's passed in. When this method is called with any object, then return the string. So this way, we're able to handle any signature. Any method signature, not just a no-art method signature. We can handle any method signature with Mockito mocking. Okay, so now let's go over here and let's create a new test. Okay, this new test will be, okay, this new test will be at test, okay, public, void. What should we say? So now we need to create a new method, right? This new method will be a time-aware greeting, okay? So rather than creating the method, I'm going to create the test, and this test is going to break. So let's do that. Let's create a test that breaks. Okay, what should be the name of a method for giving a time-aware greeting? Anybody have any ideas? Feel free to shout out. When what?
When morning?
When morning? Okay, great. When morning, then say good morning. Right? Okay, so here we go. We're going to say string name. Oh no, we don't need the name yet. We're going to say string message equals reader dot say time aware hello. Okay, that breaks right away because I don't have that method. Let's create that method. All right, we have a method. Let's return empty string. Okay, and that makes this pass. But now I want to assert. So notice I'm not using the assert not null. I can just use an assert equals and it's just as good, right? It saves me some time. Assert equals good morning world. Message. Okay. So now if I run it, that's a failure because it doesn't give me good morning world. It gives me empty string. Okay. Well, then I need to instead, what should I do? I should say greeter, time aware greeting plus world, right? Because time aware greeting is going to give me good morning, comma, or good afternoon, comma, so I just need to fill in the world. Make sense? Okay. So, is this working? No, it's not working. All right, let's take a look. All right. It wanted good morning world, but was time aware greeting world. All right. So, let us. So, when we say. Let's run all tests. Oh, so comparison. Okay, time aware greeting world. Okay. So let's take a look at what happened. By the way, remember what I was saying about how well-named tests help? Now imagine if these are dozens of tests, right? You can just go down the line and see which thing failed. When morning, then say good morning. Oh, looks like my time-aware functionality failed. Okay, that's where good names help. All right. So again, with testing, you can see that this was what was expected, and this is what was given to us, right? So, close this. All right. Minimize this. All right. Now, oh, because I'm just using the object.
And you have to call the
I need to call the method, right? Well, there we go. That helps. Let's call the method. Okay. So I'll call that particular method. And let's see what that does. Oh, infinite test says success. All right. We just inserted a mock. We have a dependency. Imagine this wasn't actually just getting local data. Imagine it was actually going to an external service. We mocked the call to that external service. We gave it canned data, and we validated that the data coming back is what we expected. Okay? So in this fashion, we can build up, through test-driven development, increasingly complex functionality in our software while making sure that not only is it properly documented, but that the functionality is thoroughly tested. And just as I showed you how we can do the good morning, we could also pass in, as I could actually overwrite it in this method. I could say in this method, no, I actually wanted to test the good afternoon. So I could have another test that says good afternoon. Or I could, for example, if I wanted to test the time-aware greeting, I could actually make the local time maybe injected, right? It's called the clock pattern, if you're curious. The TDD terminology is clock pattern, where if you're doing any time-aware stuff, inject the clock. Make the clock, the local date time, inject it instead of instantiating it. Instead of calling local date time.now, just pass in a clock. That way, in your code, in your test rather, you could hard code the clock to be exactly what you want. So therefore, you avoid any dependency on a particular time. The reason I say that, many times you have timing classes that determine when time started, when time finished. Well, that's often indeterminate based upon the speed of the machine that is executing. If instead you inject the clock, you remove that dependency and you make that test only test your functionality as opposed to being dependent upon the performance of an underlying system. Any questions?
Yep.
Yes.
Can you show me the test code for time-aware greeting?
Oh, I did not write the test code for that.
Oh.
Yeah. Sorry. Yeah, I was just sorry. This was
The reason I asked is not just to, it's because how would you test this get local time or local time now?
that was a clock pattern that I just talked about.
But I just didn't. I mean, do you mock that local time or?
Right. So what you would do is, okay, let's go back in here, right? What you would do is instead of doing local time.now, I would have time-aware greetings constructor, to use Paul's example, take the local date time object as a constructor, right? So that could be injected in real usage or mocked and then injected for test usage. And in test usage, I could set that time to be exactly what I want. Therefore, with that test, I can test what happens when the time is before noon, and I can test what happens when the time is after noon. So I can test both sides, right? Okay, does that make sense? Thank you, Preston. No, you're right. I should have written, I did not do TDD myself. I was in a rush. I'm so sorry. I did not do TDD for this particular class.
Was your manager
I know,
cracking the whip
exactly.
and said, get it done, get
I
it
was
done?
I was only partially extreme. I was not fully extreme in my practice. I was just struggling. I was like, how do I properly show a mock? And then it just struck me, let's do a time-specific thing. But I didn't have time to do the test. Thank you, though. Any other questions, folks? Well, If not, I wanted to thank you all for your time and for your patient attention. I'm very happy that the test gods were kind enough to work with my demo. Live coding in front of people is always a challenge, right? So thank you for bearing with me, and really thank you for your attention. If there are no further questions, I'll turn it back over to Paul, and thanks again for being such a wonderful audience.